remember we were here, and did I show you how to save the topology also? First is you go inside the router and give a command, either WR, which means right from the privilege mode here. You can say WR, that's it, right? Or, so when you say WR, it is writing all your commands, saving all your commands from RAM into the NVRAM, right? So I believe I gave you some information about regarding the components of a router and switch. So we have RAM, which is a temporary memory, right? All your commands that we give is stored in the RAM, right? So to check this contents, we give a command show run. Or a show run is also okay, right? Or the full command is if you press a tab, it will be running dash config. So in the exam also, I just give show run. Okay. So it will tell you what all commands we have. Uh, right. And then the main memory is NVRAM, non-volatile random access memory. So if you want to save from here to there, we go to the privilege mode or any other mode beyond the privilege mode like global mode or interface mode or outer mode, and we say do show run. That's the only difference, right? Privilege mode, remember this one, we don't have to say do, but from the global mode, if you give the command show run, it won't work, right? So you have to just add do show run. Maybe from the interface mode or router mode, whatever, do and then show or copy or whatever, right? Like that. Initially, copy commands, right? Show commands, erase. I'll show you that, right? And clear commands were given from here only. But now you can give from any other mode by prefixing do command, right? So if you want to save all your commands from RAM to NVRAM, because if you don't save it in the NVRAM, then we give whatever commands. But if I turn off the router in my lab, obviously in the real company, nobody's going to turn off the production router, right? It will be running continuously for 8 years, 10 years, whatever. And we always have design part redundancy. See, if one link or one router fails, it should automatically take the next path and go through next route, right? This is what we should be doing in the real life, real networks. So therefore, routers and switches and all these servers, they are continuously day and night on. We know 365 days, right? 24 by 7. So we are not going to turn them off, never. But in our lab, right? Let us say. So if I want my commands also, so for example, here in the packet tracer, right? And maybe in my institute, I had physical routers and switches, so many of them, right? 15, 20. So every day students used to come. We are talking about right from 2002 onwards, right? So students used to come physical classrooms. You know that there was no online things, right? No corona, nothing. So they used to sit, configure the routers and go away. Next batch guys coming, right? They'll remove all the commands and they will again configure their own. And if they save it, and if nobody touches the router again, if the same guy comes, he will get the commands next day also on the router, right? So running config. So if you want to save from RAM to NVRAM, which is a permanent memory, right? So we have to give a command, copy from where source is my running config and NVRAM is startup config. So we can just say from my RAM, the command is running dash config, or I will just say run here. And this command is start. So startup config. So you can just type start or tab or complete whole command startup dash config. But I never type. I know I never go beyond run, right? And start. Then it's up to you, right? Nothing to worry. We should know everything. That's it. So when you say copy, this is the source from where, right? From my RAM into where? Into my NVRAM, which is the destination. Yeah. So like this. So this is what we had done, I think, on Friday. Did I save it for you? Isn't it? And then we know how to save the topology also, correct? I'm trying to click, yes. Seems to be some internet problem. I'm trying to click on draw. It is not allowing me to go ahead. Okay. It'll take a couple of seconds. So the command to save from RAM to NVRAM is copy, run, start. From any other mode, global mode or interface mode or outer mode, whatever, we'll see that all different modes. We'll say do, copy, run, start. Okay. And vice versa. If you want to again get your commands back from NVRAM into the RAM, what do you say? Opposite. Copy, start, run. Opposite of this, right? Yeah. So source first, the syntax is first source and then the destination. So copy, run, start. So it will save all your commands from here to there. Now, even if you turn off the router, off the switch, you'll still get your commands back, right? Once you again next time turn it on. So, and so therefore, we are on which router? So here, see this one, let's check. This already has got 10 on 3, correct? And a default gateway of /24 means 255.255.255.255, and 10.1.1 is the default gateway, this guy. And this guy already has got 10.2. It won't show you here, but we'll have to go inside and check. Oh, it's showing here. Normal this, I don't know, what's the software issue. 10.2, look at the down bottom or down below in the center, right? VLAN 1, 10.2/24. And this router has got gigabit 0. I have taken it on the left. I always take it on the LAN, right? Gigabit 0. Look, that is 10.1.1. So now we'll go on gigabit 1 port and give an IP address of 20.1.1.1. And yeah, and this guy 21.2. So if you want to check its routing table, let's check this guy's routing table, right? Show IP route. Very simple command, don't worry. Enable show. I don't have to type SHOW also, right? I just type SH. If you press tab key, if it's unique, it will show you. Show IP route, ROUT or route, whatever you call it. Show IP route. Okay. This is the routing table of a router. Don't worry, guys. Don't be afraid. It's just like a pre-advertisement or trailer. Actually, we'll be getting into the router and looking at all these things in lot of detail after a month, right? Or whatever, 20, 25 days, whatever. Okay, so don't worry. So this is the default name of the router is router only, right? Show run. I press tab, right? So look, these are the default settings, routers commands coming from the factory only. None of the port has got IP address, right? And all of them are shut down. So you got to enable all these ports, right? Okay. Once again, up arrow, space, 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 right? Space means it will show you all these 15, 20 lines, whatever commands it can display on a page. So we'll explore all these things later on, right? Host name by default of a router is router only, and that of a switch is switch only. So speed and duplex are auto. There's no IP address and all the ports are shut down, right? By default. You got to enable it. Some of the commands we don't have to explore in this course also. We'll be looking at this. It has got a console port. Look, it has got a console port wherein actually this is a console port, RJ45, and one more, USB. So if this fails, or you have only this connector, you can connect your laptop here and start configuring or viewing the commands, right, of your router, or start configuring your router. If in case you have this RJ45 connector, you can connect it here. So this or that, but only one thing will work at a time. So to configure, supposing you go and buy a new router. Now I have kept it on the table here, and I have a laptop also, and I can touch both of them within 1 meter. So I want to configure, so I'll connect a cable and I'll tell you what cable and how does it look and all those things, right? Shortly. So I'll connect a cable from my laptop and open a software known as Hyperterminal or Putty or Super Putty or whatever, different softwares, and then turn on this router. Similarly, I'll start getting output here like this, right? Is it okay? Understanding everybody? This is going to be a physical connection, right? And these are the default settings of the router. So we have a console port. We have an auxiliary port. Where is it? AUX. Zoom in. So I think look at this one, AUX, right? Auxiliary port. So in case both of them fail, you can connect the cable here and then start configuring or viewing all the commands from here also. Okay. So lot of choice. Earlier, auxiliary port was used for some other purpose also. Earlier, not nowadays. So what did I tell you? We have one console port like this, RJ45, right? Console. We have one more USB port, right? Console only. And now we have an AUX port also auxiliary. So earlier from my laptop, right, I will connect this router like this to here. If I don't have RJ45, then I'll connect it here, USB port, right? That's fine. Anywhere you connect it, no problem. But only one thing, only one port, either here or there. If both of them fail, then I can connect it now to the auxiliary port also. But in the olden days, what used to happen is telephone company, telco, right? We used to have a modem and that used to go to the auxiliary port, right? So here a telephone line, right? Telco is telephone line. We had a telephone line, right? Remotely at my home, let's say, imagine I got a laptop, right, which is also connected to a modem, and that in turn is connected to the telco, right? So if this router is turned on, right, everything is turned on, this boxes, right, modems, whatever, and then remotely I could dial in and start configuring my router, right? So auxiliary port was actually used for that, but nowadays we don't use this telco connections or all that, right? So one is console port here. So one is console port, RJ45. If that fails, USB port. If that fails, auxiliary port, right? So three choices. And these are your built-in 3 gigabit Ethernet ports. And this is power on off button. And this is the cord and some LEDs. And this is the backside of the router, right? I told you we can insert some more ports here, right? Or I can insert my 4 fingers. I can also cover it, but we need to turn off the power, right? First. Okay. More details will come up. Now look, switch is a plug and play device, right? So you just took a PC, connected to a switch, they became green. Switch port green, router this port because we had set no shut here. This became green, so enabled. So this will also enable itself automatically. But these are red. That means, look, the switch port is also red. Why? Because it's connected to the router, but the router's just this gigabit port is disabled, shut down. So if you go and say here, no shut on this router, R3, then that switch port will automatically become green, right? So we have to say no shut here, no shut here, no shut here, no shut here. And of course, we have to give 21 on here, 21 on 2, 31 on 1, 31 on 2, 41 on 1, 41 on 2, 41 on 3. Is everybody comfortable so far understanding what I am trying to say here? Yes. Aditya, Bharat, Dipti, Karthik, Neeraj,
Yes, sir.
Prabhamani, and Supraja.
Yes.
समझ में आ रहा है ना? समझ में आ रहा है means understanding, guys. Yes or no? Isn't it right? So let me go here and give an IP address 2111. So how do we do this? We click on the router, go on CLI, command interface, press enter. What does it say? R1 console 0 is now available. Press return to get started. So I am pressing enter, 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 enter. So this is the first mode. Everybody knows user mode. We give a command enable. EN also is okay. Conf T is also okay. Or you can give configure terminal, right? I normally give this only conf T. But for now, configure terminal. And we come to the global mode. So user mode enable got us to the privilege mode or enabled mode, and configure terminal or conf T gets us to the global mode. Now, if you want, from here only I could have said show IP interface brief command. But from here, if I say show IP interface brief command, it won't work. So I have to first type here do, and then look from the privilege mode. If I type here sh tab, it will complete the command show. But from here, if I am pressing tab, it doesn't. Okay, it won't. But if it's unique, it will execute. Do show IP int. If I give the same command show IP int from the privilege mode, and after int, if I press tab key, it will complete interface. Here it won't, right? But if I type br here and press tab, it won't. But from there, if I type show IP int br tab, So for BR, it will complete brief, right? But that's okay. It will still show me the output here. So now look, I got 3 gigabit Ethernet ports, gigabit 000. We have given an IP and this is enabled, right? Up and up. Status and protocol means enabled. Both should be up and up. This is physical layer of the OSI reference model. We'll talk of that later. And this is a data link layer protocol. So if I send a signal hello, I'll get back a signal, right? Whatever. That means from this port, gigabit 000, I can send and receive data now, right? And gigabit 0 is now connected to the switch in the LAN, right? So let's say this is a WAN, whatever. So now I go on gigabit 1, and what did we say? Nothing here. They are all disabled. So we'll type here interface G tab 0 oblique 0 oblique 1, right? Look, follow this syntax exactly. So I want to configure this port. So I can say first no shut, or I can say no shut later on. Before that, I can give IP address, whatever sequence doesn't make any difference. So what do we want to give? 20.1.1.1 and 255.255.255.0. Is that okay? So look, to do all these basic configurations, we don't require any qualification or prerequisite, right? Even a 10th guy or 8th standard guy, right, or a girl can simply do it if you just tell him, right, hello, this is how we do it, right? That's it. So I don't think we require any technical qualification. I don't need to be a B or a B Tech or a ME Tech or whatever, right? Even BSc Computer Science or diploma in electronics, or I don't need to be a science guy, arts guy, commerce guy, anybody can do it, right? So I have given this IP address 21 and 1. Is it correct? Check 21 and 1. But I said no shut, yet it is red because we got to go on the other router and say no shut to the gigabit 0 opposite connected port, right? Then both of them will become automatically green. I hope we said no shut here, right? Remember, we have said in case we forget, then problem, right? So now we'll go on this router and say 21 and 2 here on gigabit 0 and 3111 on gigabit 1. Okay. So let's go there. So enable, sorry, wait a sec. Which is this router? Have we given the host name to this guy? Let's give host name. Yeah, we have given R1. So I would like to give R2 and R3, right? R2 to this guy and R3 this guy. Let's first give a host name. Privilege mode, configure terminal, conft, host name, HO tab, capital R2, interface, I think gigabit 000. Please make sure you draw it on a piece of paper and keep it in front of you. This is gigabit 000. I want to give here 2112. Okay. And some subnet mask, right? I'm just taking randomly some subnet mask and no shut. Okay. Now look, physical layer has come up. Line protocol data link layer also has come up, right? Gigabit 0. Now if you give a command do show IP interface brief. So look, gigabit 0 up and up 2112. Okay, good. So now gigabit 0 can also send and receive data. Gigabit 1 is should be 3111 and is not enabled also. So let's go on gigabit 001 and give 3111. Okay. So what we can do is up arrow, up arrow, up arrow, up arrow, backspace 1. Okay. Because whatever commands we give, this router stores 10 commands in 10 lines, right? So up to 10, latest it will keep on storing. It creates a buffer and stores all these commands, latest 10 by default in that buffer, okay? Memory. So we can say control P, 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 P for previous commands or up arrow, up arrow, up arrow, down arrow, whatever. Control P for previous commands, control N for next commands, or up arrow, down arrow. Up arrow for previous, down arrow for next commands. Okay. So now I'll say no, shut. And I would like to give an IP address of what, guys? Gigabit 1, no mistakes, 3111, right? Correct? Make sure we don't commit mistakes. Even if we spend some more time in cross checking, no problem. I think Superja is facing some internet issues. Okay, so are we done? Do show IP
Excuse me, sir.
interface brief. So look,
Excuse me.
yeah.
Sir, we have given 255.255.255.0 in the previous port also.
Hmm.
So is it okay to give the same one or should we
Not
change it?
necessarily, Dipti, don't worry.
Okay,
I,
okay.
I, I got your point. Right?
Mhm.
Not necessarily. I could
Okay,
have given maybe something else between these two. Got it?
okay, okay.
We gave here 22250. I could have given maybe just an example, right? But
Okay,
don't worry if you don't understand. Right
okay,
now, when we do all these things, I will explain you exactly
okay,
hyperthreading and subnetting. But I could have given here maybe 255 255 Just an example. Huh? Maybe I can give here 255 but here also I'll have to give same 255 Just an example. Maybe I can give here 255.255.255.252, and here also, sorry, not here. Maybe between these two, between the two routers, 255.255.255.252, here also 255.255.255.252. And those of you understand why I am giving this example, and so they know it why. Because we just require two IP addresses. But anybody who says, man, what is all this foreign thing? I don't understand anything. Don't worry. Right now, just I have given some MAC addresses and some IP and some subnet mask, and we are just going ahead. Later on, I will tell you what is the implication of 255 and why not 255 or why not 255 or what will happen if we give 255 right? So all these things I'll explain. Don't worry at all. If anybody is totally new to IP addressing and subnetting, right? And trust me, it will take some time, but it will come out. Right now, we are just giving some IP addresses. Of course, look, you can't give here 30 dot and you can't give here 40 dot. Both of them need to be in the same network or subnet, right? At least this much everybody is understanding, right? Subnet mask also opposite, you have to give same only. You can't give here 255 and there 255 right? You can't. But here, these two can have something same but different from this guy, right? So, okay. ठीक है अभी के लिए for now is it okay Supraja who asked
Yes, yes.
okay so don't worry guys anybody don't take tension I am not understanding anything about what is this IP address and subnet mask I'll explain that but we have taken here 10 dot something we have taken in between these two 20 dot something we have taken here 30 dot something and we have taken here 40 dot right so obviously all of these should be in the same network or subnet right at least to begin with and now where are we. Okay, here I have given, let me just keep my cursor there. At least I have given the IP address. Now it should not be red, but we know why it is red on gigabit 001 because the right router, gigabit 001 is shut down. Right, so you have to say no shut on under both the interfaces. So I think here we have said no shut, right? And better cross check again, gigabit 001. Have you said no shut? Yes. Look, we have said, right? And so now let's go on this final router R2, whatever. I'll give a host name of R3, R1, R2, R3. And here, gigabit 0, I am taking into the LAN, right? You can take it anywhere, right? Not a rule. You could have taken gigabit 0 here, gigabit 1 there. But normally, just to remind myself, I take gigabit zeros in the LAN, right? So rest is all up to us. So now I'll give here gigabit 1, 3112. Okay. First is the host name, R3, and interface gigabit 00. You can take any interface first, right? No, shut. And make sure you give the correct IP address. Don't mess with this, right? If you're not sure, go and check again. Gigabit 1 should be 3112. Okay. Because later on we'll have to spend more time troubleshooting why things are not working. 3112, but a space here. Dot 2. And again, some subnet mask, for example, 255, not 225. Okay. And so gigabit, and now I can say gigabit 0 port is 41 on 1, right? We know this. Gigabit 0 going towards the switch, that's 41 on 1. No shut. And up arrow, 41 on 1. Is it okay? So far, so good, everybody. So do show IP. This is a very lovely command, right? IP interface brief. And the full command is brief. So look, I am using two interfaces here, gigabit 0 going towards the switch, up and up, very good. 41 on 1, very good. And this was 31 on 2, we know it, correct? One way of checking, and obviously because this is software, right? On the real, in your company, when you're working on real routers, obviously we don't have anything like this. So 41 on 1 is going on the right gigabit 0 towards the switch, and gigabit 1, 001 is 31 on 2, correct? Yes, correct. This one, check this one. Gigabit 0 on the left should be 2112. I'm comparing with the sticky note that we had given earlier and pasted there. 3111 on gigabit 1, correct? And of course, we have checked this one. Gigabit 0 is 1011 and gigabit 1 is 21. Okay, good. Now let's go and check this, guys. Now look, all green. Very good. Now let's go and check on this router. Control Z. So when I press Control Z, see, from the interface mode, it straight away came back 2 steps back, right? I'll explain you all these things, don't worry. No need trailer going on. So from the user mode, if I type enable, it will come to the privilege mode. From here, if we type config T, it will come to the global mode. Of course, here the name of the router will be, by default, it is router, but because we change it, it will be R1. I'm not writing here, right? And inside the bracket, we know it's all config written. This is your cursor is blinking, right? So if I press here exit, it will take me 1 step back to privilege mode. Got it? Or if I type here end, then also it will take me to the privilege mode. Okay. But if I type here interface, gigabit, whatever, so it will bring me to the, let's say, interface mode, right? So that means I'm not writing here. It will be like this. Config dash if mode. So we are at the interface mode. Now I can give an I% no shut, right? We can type no shut also. If I press here exit, what will happen? It will take me back 1 step back, right? Config to the global mode, right? Exit. But if I don't type here exit, if I press here Control Z, right? Control Z, it will take me straight away 2 steps back to the privilege mode. Got it? Control Z or end will straight away jump 2 steps back, direct from the interface mode to the privilege mode. If you wanted to go back only 1 step to the global mode, then you have to type exit. ये समझ में आ रहा है दोस्तों? Everybody understandable? Understood? Yes or no? Yes, guys? Okay.
सर
Any
यस सर
difficulty? ठीक है कि नहीं है?
सर यूजर मोड में क्या एक्शन होते हैं लाइक एवरी टाइम वी आर गोइंग इनटू इट साइड
User mode, very limited commands, right? You cannot configure everything. So very limited commands, user mode, right? See,
ठीक
now
है
look at this. So if I type here disable, it will take me back to the user mode. See this? Hmm? If I type here exit out from this console, right? Entry right from the beginning, right? Welcome back again. So as if now I'm connected, right, to the router's console port and getting in. So now it says this is from the beginning, right? Right from the beginning. Okay, now look, enter. So if I press a question mark, of course, this is a simulator, but see, you cannot configure many advanced things from here, right? So from here, very limited commands are possible. Got it?
या
Yeah.
थैंक्स
Okay. So we have to say enable and go to the private mode. From here, yes, many more commands. From A to Z, lot of commands. Look at this. Dil mange more. More means there are yet many more commands. A few or more, I don't know, but there are commands after this. So if I press here, enter, enter, enter. After reload, enter. So one line, one command. See that? Resume. Enter, enter, enter. Can you see that down below? Right? Setup, enter, show. So if I press here tab key, it won't show me any other further output. I don't want to have a look at further outputs, right? Tab. See, it will break here. Okay. Once again, I'm just pressing here shift and question mark. Right. So I typed here question mark, nothing else. So from A to Z, telling me what all commands I can give from this mode. Okay. So we know configure terminal, configure space question mark. Then you'll get one choice, terminal. Then you have to give that. Okay. Anyway, ping. Okay. You can give from user mode. I think you could give from user mode as well as privilege. This one, yeah, from the user mode also and from the privilege mode also. But this one, yeah, it did show. Did it show? Yes, user mode, ping. Possible from user mode as well as privilege mode, right?
Okay.
This is which
Parents.
mode? Privilege mode, right? Ping, telnet, trace route, both modes. Okay, where are we? So, look, once again, question mark. Tab, break. Enter 109. And if I press space bar, after reload, space bar. So after reload, it gave me remaining commands. But remaining commands were how much? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, whatever. But had there been 100 more commands yet to be displayed, I would have pressed enter, sorry, space bar, space bar, space bar, space bar, n number of times. You get it? One space bar means it will show me maybe uh, whatever this 15, 20 lines. So that means let's say 20 lines. And if still 100 more were left, I would have pressed space bar 5 times or 4 times, whatever, to see all the commands. You get it? So question mark. Tab means break. Don't show me any command. Right? Space means show me, keep on showing me whatever further commands, 15 or 20 commands, if at all, right? In a group. And enter means one line by one line, right? Line by line, just one line. Where are we? So let me go and check this guy's routing table. First command that I love to give is always in the exam or everywhere. Show IP interface brief. Check always before you proceed in the exam or wherever, whether all your interfaces are up and do they have the proper IP address also, right? Check that. So if you don't know what subnet mask, could also be wrong. If you don't know, then go and give the command show interface gigabit 000, right? Show interface or interfaces gigabit 0/0. Just an example, right? So here it will tell you up and up. Very good. And now we had seen this before also, but now we can see the subnet mask also, right? And I'll take you into more details later on, not right now. Okay, very good. Now show IP interface brief is good, seems to be good. Both the ports are up and IP address is also okay, right? This is lovely command. Now let us check the routing table. Show IP route. What does it say? Okay, don't worry. All these details will come up later on. This is only a pre-advertisement trailer, right? So don't get afraid if you have any doubts or anxiety, let me know. It is giving you a lot of codes here. Nothing to worry. Gateway of the last resort is not set, okay? And a few entries here, right? I told you if the router is the ports are not enabled, right? It won't show you any entry here, right? If you take a router, let me take a new router. Click it, CLI, booting up, right? It's booting up. It is loading the iOS file from the flash into the RAM. And I'll tell you more about this, don't worry, later on.
सर ये कब होता है? तो ये जो
Sorry.
so when do this happen?
So you just turned on the
Improves.
router, right? Initial stage, isn't it?
Okay.
It started booting up,
Okay.
correct? And so it was, I'll tell you more about it, don't worry. Problem is that I will tell, but the tell will take some time, right? So look, what all components we
Sir,
have
if
in the
we
router
switch
switch.
off and switch on, the config
Sorry?
will disappear. If we switch off and switch on the router, will the config disappear?
Yeah. If you turn it off and again turn it on, yeah, isn't it?
Hmm.
It will boot up.
Yes,
You're
yes.
right. You're right. But obviously we are doing it here in the lab and simulator, but in the real company we won't be doing it, isn't it? It's a production
Right.
router. Then we won't be able to do.
Right.
Okay. So now when it comes here, it means a setup mode. That means this router is on the factory defaults, right? Is on the factory defaults, or somebody has erased all the commands from the NVRAM, right? And said reload. I'll show you all these things. Don't worry. That means we have got it on the factory default. It's asking me whether you would like to go to setup mode, yes or no. So I don't want to go there. And setup how to go there and what do we do there? That also I will show you as a demo. But in the real life, we never go there in the setup mode. So I am on the user mode. Enable. Show IP route. See, I came here. I took a new router just to tell you there is no entry here. See, why? Because all these ports are shut down, right? If it sends a hello, it doesn't get a hello. No signal going and coming. Look, all the ports are disabled by default. So even if you, right, disabled port means it cannot send any signal. By the way, if I just go there and say interface gigabit 0/0/0, and if I just say give an IP address, let's say something and some subnet mask, and if I go to another port also, and if I say if I give an IP address of, let's say 2.1.1.1. Now 1 dot and 2 dot are different networks. Do show IP interface brief. Even now, even though I have given IP address, but the ports are still disabled. It cannot send and receive data, right? So unless and until you have connected, even if you say no shut, now what's happening? Do show IP route. See, even if you have given IP address, but the ports are disabled, no entry in the round table, right? So let's go and say no shut. Now look, physical layer has come up, but data link layer will not come up. Why? Because from that port, we have not connected any other device opposite it. And there's no cable in between, right? So I don't know which port was that. Okay, so let's make it gigabit 000 also. Do show IP interface brief. Do show IP. Okay. Now look, we have given some IP addresses. They are different networks. Fine. Oh, I forgot to say this guy. No shut. So let me go on gigabit 0. I don't know which port is that. 0/0 and no shut. Okay. Shut. Now again, do show IP interface brief. No. Yeah, check this. IP addresses are there. Physical layer has come up, but data link layer still is down. Protocol, right? Status is up, protocol is down. Why? Because we don't have anything connected. Here, now if I send something, I can get back a signal also. So nothing in the routing table. What does it say? Do show IP route. Any command here? Yeah. So see, no entry. Okay. So now here it will say, I know. Now it will show you two entries. C for connected, L for local. C for connected, L for local. Right? C for connected means exactly 10.1.1.1, but it belongs to 10.1.1.0 subnet. And those of you who are not aware of all these things, don't worry. Right? See, look, it says exact. L stands for local. C stands for connected. So what does it say? Gateway of the last slot is not set. Okay. Now it says, I know I don't look at this entry because I don't see anything on the left here. Right. So I don't look at this. And I personally, I call it, I don't like this. So I call it stupid entry. I don't look at this also. Personally, I don't like it. So personally is me only. But Cisco will say, go to hell, man. You Tom, Dick, and Harry. Only Tom. Why Tom, Dick, and Harry? Right? Because Cisco is such a big whole world, right? Uses this technology and does certifications and gets jobs and makes families and kids happy, whatever. So, but I don't like this. I don't even look at this. But this, and I call it when I'm alone. I mean, I should not be saying in the class. I'm a stupid entry, man. I don't even look at it. Don't bother to look at it. It says, man, I know 10 network. /8 means subnet mask. Well, I have not given 255.000 anywhere yet. I've given only /24 on 10.1.1, right? So it says it's variably subnetted, 2 subnets and 2 mask. 2 mask means it is considering Okay, connected. Look at this connected and local. Local means exact IP address that we have given on this interface. Which interface? Gigabit 0, of course. We have given 10 on one. And what subnet mask have we used there? 222.550, which means what? /24. Right? And so it says /32 means this is the host IP address. That means this very IP address 10.1.1 we have given on this port, gigabit 0. Fine, we know it. We only have given it. So it says local. Okay, it's directly connected. Fine. But this IP address belongs to this subnet. And if you don't understand subnetting and all those things, don't worry. Boolean landing and all those things. What essentially is this is a subnet address and this is a host IP address, which means what? Let us say this is KGA and this is we have 10 students in KGA, right? KG, I'm talking about the preparatory school, class 1, class 2, right? Our childhood days, right? I don't know whether everybody understands KG or not. In my right school days, when I was toddler to 5 years old or 4 years, I don't know, I was put in a KG class. You call it prep. I don't know what nowadays you call it, but I hope everybody understands standard 1, standard 2, and below that is KG or something like this. So this is KGA classroom. In that classroom, we have 254 students sitting, right? 5-year-old kids, toddlers, and this is roll number 1, right? Like, right? The IP address is so in a LAN, we can use just an example here 254 to 254 devices we can have in the LAN, and to them we'll give addresses like this, maybe 10.1.1.1, 10.1.1.2, 10.1.1.3. So any of these 254 guys belong to KG class, or they all belong this subnet, this host IP address belongs to this subnet IP address. समझ में आ रहा है दोस्तों? Understanding this or not? Is it difficult? Anybody who's new to IP addressing? KGA, this is the classroom, right? But we got 10 students here, roll number 1, 2, maybe 254 students in a class, right? So look, you cannot give a roll number as KGA. Roll number will be 1 to 254, but they all belong to which class? KGA. Likewise, 10.1.1.0/24 is a subnet IP address. It cannot be given to any device. But in this subnet, you can give IP addresses like this to all the devices. How many devices? Maybe 254 devices. 10.1.1.3, 10.1.1.4, so on and so forth till 10.1.1.254. Right? So these IP addresses belong to this subnet. You get the point? My roll number cannot be KGA. My roll number has to be 1 or 10 or 50 or 100 or 200 or 254, because maybe this subnet mask is permitting us to have only 254 IP addresses in this particular subnet. Okay. So something like this. So this is an exact IP address, which is /32, but it belongs to this subnet, right? And this will contain, both of them will tell you, later on we'll discover that you can have up to 254. But right now, don't worry, even if you don't understand, right? Okay, now where are we? So we are having a look at the routing table. So for now, what's happening? Enable. See, look, if I don't touch the keyboard for 5 minutes, it throws me out again, right? Show IP route or route. So now I don't look at the stupid entry, but I understood now there are two subnets and two masks. Two masks means this /24 is one mask, subnet mask, and this is another. And I don't even look at this stupid entry also local. And believe me, for a couple of decades, there was only two entries, CC. The LL was not there, right, for many years. But now I don't know why they have added LL also. But we know what it is, L for local. So to gigabit 0, we have given exact IP address, this one. But the subnet mask we have given there is here on the top, right? And this IP address, which is a host IP address, means 32, it belongs to this subnet. Got it? This is the subnet IP address. हाँ दोस्तों, समझ में आ रहा है? Yes, friends, understanding this much for now, at least to go ahead. Likewise, it says, I know of this subnet, right? 20, which means what? Which is directly connected on gigabit 1, which means what? The router says, man, I may be a router, I may be ISP's router, I may have 200 ports, I may have 200 devices connected to me, right? And if I get a packet from anywhere whose destination is 21 something, I'm going to forward from which of my port? Gigabit 1, says R1. If I get a packet for 21 and something, I'm going to forward from here, let's say. I'm going to forward from which of my port? Gigabit 001. Is this understood, guys? R1 says, if I get a packet from anywhere for 21 and something, I'm going to forward from gigabit 1. Okay? If I get a packet from, let's say here left, for 21 and something, I'm going to forward from it. But if I get a packet, let's say from my right, whose destination is 10 and something, I should be forwarding from my gigabit 0 port, correct? So let's check this. 10 is gigabit 0. If I get a packet from anywhere whose destination is 10 and something, I should be forwarding from which of my port? Gigabit 0. Is this understood, guys? Only look at C entries. Don't worry about L. Yes? So now router says, I know only of two subnets or networks, 10.11 and 21. That's it. But look, he says, I know of 10 and 20. How? Because they are directly connected, right, to me. Because they are directly connected to me, right? So I can forward data to them, 10 and 20. Which means what? Like this. 10 and 20. So supposing if I get a packet from here for 10 something. Understood? 10.1.0/24. So this is gigabit 0. And 20, right? This is gigabit 1. So if I get a packet from here, anywhere, for 10 or something, I should forward from which port? Gigabit 0. But if I get a packet whose destination is 21 or something, I should forward from which of my port? Gigabit 1. Correct? That's what the router is telling. Okay. No problem. Okay. So we understood this. Now, likewise, R2 says, I know of 20 and 30. 21 and 0 and 31 and 0. Gigabit 0 and gigabit 1, right? Check. First is show IP interface brief. Always check this. All my ports up and up. Fine. Gigabit 0, 21 and 2. Gigabit 1, 31 and 1. Gigabit 0, 21 and 2. Gigabit 1, 31 and 1. Okay. Fair enough. Now check. Up and up. Very good. IPs are good. Okay. Let's check the routing table. Show IP route. Now look, what does it say? I know of 21 and 0 and 31 and 0. That means if I get a packet from anywhere for 21 and something, I'll forward from my gigabit 0. And if I get a packet from anywhere for 31 and something, I'll forward from my gigabit 1. Understanding this, guys, easy, right? No problem. Likewise, this guy will say, I know of 3110 and 4110. Right? If I get a packet from, let's say from my right for 31 and something, I will receive on this port, but I'll forward from my gigabit 1 port. Right? Likewise, if I get a packet from my left for 41, I'll receive on gigabit 1 port and forward from my gigabit 0 port. Right? So I'll forward for 40, I'll forward from my gigabit 0 port. Got it? I think it's mixing up, but we know gigabit 0 we have taken here only, right? So 40 means gigabit 0, 30 means gigabit 1. Check. So IP route directly, right? Because we know all are up and up. So 40 is going in the LAN towards the switch, that is gigabit 0, correct? And 30 is going towards the left router, gigabit 1, directly connected. So now all the interfaces are up and up. Now if I go and ping from my PC to the switch or my default gateway 10 on 1, will it ping? It should ping, na? All of them in the same network. Go to desktop, come to command prompt. Let's type ping. Ping is to find out connectivity. From my PC, I am pinging my switch, which is what? 10.1.1.2. So is it pinging? It should ping. Yes, it is pinging out. It's pinging. So I am sending a packet to this guy. First packet got dropped there because see, I sent 4 packet. First got timed out. Why? Because this guy got busy making an entry in its ARP table. In its ARP table. What entry did it make? This guy is the packet that came in, or the frame that came in. It took this guy's MAC address and the IP address and noted in its ARP table. Look, this is 1013. Let's go and check this guy's ARP table. Enable show ARP or show IP ARP, whatever you want, right? Show ARP. What does it say? Switch. Who's 1013? The PC? And what is its MAC address? I only look at the last one, 7889. I can't remember the whole thing. Easier for me to just check the last 7889, correct? Let's copy. This must be the MAC address of the PC, correct? Copy. 1013. So look, it's in VLAN 1 and it has made an entry automatically in its ARP table. Now let me go here. What is this guy's MAC address? We are pasting it here, right? See, 7889, right? I pasted it here, correct? How do we check this guy's MAC address and IP address? We go on the close this. Okay, we are here and we'll type here IP config, right? Everybody knows this IP config. So it's telling me IP config that the IP address of this PC is IPv4 address, right? Is the subnet mask and default gateway. But I don't see the MAC address. So what's the command? Up arrow space / all, right? Now ipconfig space / all. Now it's telling me the physical, which is the MAC address. Is it same? 7889, correct? 000A 4. I don't remember this. I just look at the last one. 7889, right? But you can check the whole one, correct? Is it same? Yeah. Right? So we know. And of course, we know that it is 1013, right? So the switch, when the first ping packet came from the PC to the switch, it took some time to make an entry in its ARP table. This is its ARP table, right? So it took this IP address and made an entry here. Okay, this MAC address and this IP address, right? So it got busy, so it could not answer the first packet of the PC. But the moment he made entry, this guy sent, okay, so this guy, after sending 1 packet, he waited. Where is it? Right, where is it? Okay, so when it sent the first packet, it waited, it didn't get a reply back. Okay, and the second packet it sent, but it got a reply back. TTL is time to leave, right? So time is equal to milliseconds, whatever. So it got a reply back. Third packet also it sent, it got a reply back. Fourth packet also it sent only 4 packet. So of the 4, first packet it didn't get a reply back, but for the 3 it got. So the PC sent 4 packets. That was the destination IP address, and it received only 3, lost 1, 25% loss. But remember, even if you just get 1 reply and 3 no replies, even then the connectivity is there. Got it? Even if it is 75% loss, even then connectivity is there. It's only when you don't get reply for any of the packets, that means the connectivity is not there between me and the destination, right? Whatever it is. It can be remote, it can be directly connected. Okay. Understanding this, guys? This command, for if you are working on Mac or some other operating system, you can give if config, if, not IP. Okay. Into if config. Okay. Cisco wants you to know for the exam all these tidbits. So now where are we? So I pinged from the PC to the switch. The connectivity is there. So on the switch also you can go and ping the PC. Okay, now let me ping from the PC to my default gateway, 10.1. Make sure your PC's default gateway is correctly configured. Otherwise, big problem. It won't be able to communicate with anybody else beyond this network, right? So I'm going to now ping whom? Up arrow, up arrow, up arrow. 10.1.3. No, sorry, 10.1, right? That's the router. Can it ping? Oh, yes. I have connectivity. So if I don't get connectivity, so let me say I don't have any address beginning with 4.4.4.4, right? There's no PC only or nobody now network, right? So look, when it doesn't reach anybody, it has got no connection, right? Obviously because we don't have any host only in this network, right? Nowhere. So now look what's happening. It could ping this guy, it could ping this guy. Now what's happening? Now tell me guys, PC, left PC, will it be able to ping the right PC? 41 and 3? Yes or no? I don't see anybody red here.
One question.
Yeah.
When we are sending the first packet,
Mhm.
sir.
Yeah.
So even for the router also, it makes a ARP entry.
Yeah. Router will also make an entry. Go and check this guy's ARP table.
So first time it will drop the packet. First packet will be dropped for the router.
Yeah, it may be, right? Show IP, ARP or show ARP. Check router. Look, router itself is 10.1, right? Correct?
Right, right.
And this is the router's interface address. What is this? BD01. Let's go and check. Show interface. Which port? Gigabit 000. Right? Look at this. Show interface gigabit 000. This is the IP address subnet mask. And look, this is the BD01 MAC address of router gigabit ports. Right? Interfaces MAC address. Is it BD01? Let's copy this. I don't need to, but okay. So this is the router's interfaces MAC address. V. Okay. What did we see here in the router's table? Whose PC? PC is 10.1.3.7.8.8.9. Is it correct? PC 7.8.8.9. Is the PC 7.8.8.9 correct? What about the switch? I don't know. Let's go and check. Show interface VLAN 1. Because IP address is by default given to interface VLAN 1. Up and up, turn on 2, and what is subnet mask? 0E89. Right, let's check this. Copy, paste it on the switch. Sticky note. Oh, sorry. We have here only. So we can paste it here only. 0E89. Isn't it? So, show IP ARP 0. No. Where's the switch? Switch is 10.1.2. 10.1.2 is not here. See the switch. 10.1.2 is not there. Correct? Who's 21.1? That is, it's another port, right? Connected to the router. But the switch is not here. So let's go and ping from here to the switch, which is what? 20.10.1.1.2. Correct? Can the router ping the switch? See, it's a router or switch sends 5 packets. First packet it sent 5 packets. It didn't get reply for the first 2 packets, right? But for the remaining 3, it did get the reply, right? So let's go and check now. It's ARP table. Switch is what? Now we have 2 also. This is switch and its MAC address is 0E89. Correct? 0E89. Anyway, but you get the thing. We are going too detailed, man. I didn't want to go into all these details, but okay. Now, my question was, will PC1 be able to ping PC2? Yes or no? This guy is 41.3. Oh man, we have not given the IP address, right, to this guy. So let's go and give this 41.3 desktop IP configuration 40.1.1.3. Subnet mask. We are just taking it 222.550 and default gateway should be what? 41 and 1. Is this correct? Make sure default gateway and IP address they begin with 4040 only. They should be in the same network or subnet, right? Explain this more later on. 41 and 3, 41 and 2. This guy we have not given. 41 and 1 we have given here. Correct? Gigabit 0. This guy I haven't. 41 and 2 should be. Show interface, VLAN 1. So this is shut down and there is no IP address. So we'll say configure terminal and we'll give a hostname of switch 2 and interface VLAN 1. No shut IP address 40.1.1.2. 222.550. Done. 41.2 222.550. So it doesn't show here like this. So then my only choice left is Supraja admitted. Do show IP interface brief. Yeah, brief. In the end, check VLAN 1, 41 and 2, up and up. Right, fine. So now my question is, will the first PC be able to ping 41 and 3, this PC? Yes or no? I'm giving you a big picture, don't worry. This technology will come later on, but it's very easy. Yes or no? Anybody?
Yes.
Yes, good. Who answered? Who answered?
Deepti.
Dipti, good. Okay, anybody else? Yes or no? No idea. Tell me no idea. Yes or no or no idea? Three choice. Aditya, yes or no? Or no idea? Not sure. Aditya, are you there? Bharat, yes or no?
Sir, tell me, sir.
Yes or no idea? Not sure. Karthik?
I think yes, because all ports are green.
Dipti? Neeraj? Prabhamani? Supraja? Yes, no or no idea? All the ports are green. But look, it won't ping. Why? So I'm giving you a big overview, right? Straight away. Nobody will start the course like this. Nobody. But trust me. So we have R1 here. We have R2 here. I'm building your understanding first, right? This is what? 10.1.1.1. This is 10.1.1.2. This is 10.1.1.3. This is 21.1.1. This is 21.1.2. This is 31.1.1. This is 31.1.2. Right? This is 41.1.1. And this is 41.1.2. And this is 41.1.3. Right? So what did we see here? I'm only looking at the C. I'm not looking at the LL, right? It said I know of 10.1.1.0/24 and let's say connected on gigabit 0, correct? And it said this gigabit 1. I also know of 21.1.0 subnet on gigabit 1. Likewise, connected. I know of 21.1.0 subnet. Let's say this is gigabit 0. Directly connected on C means directly connected on gigabit 0 port. And 30 similarly 110 on gigabit 1 port. Let's say this is gigabit 1. This is gigabit 0 and this is gigabit 1. So he says, I also know of two directly connected subnets. Which are they? 31.1.0 on gigabit 1, correct? And 40.1.1.0 directly connected on which port? Gigabit 0. Now look, my question was if PC1 sends the data to PC2, will it ping? So we got an answer yes. But actually it won't. Why? Because PC1 knows what's my IP address. It is 10 dot something something, right? And I pinged whom? Destination is whom? 41.3. So it knows that 40 is not my network. It's in a different network. So I need to send it to my default gateway. So which is my default gateway? It is this one, gigabit 0, 10.1, correct? Till this point, everybody okay? Yes or no?
Yeah.
Good. So it should send a packet. It should come till this point, right? Which is default gateway, right? Logic is understood. Now, what does the router do? When the packet comes, what's the source IP address? It is 10.1.3. What's the destination IP address? It is 41.3, correct? Yes or no in the packet? So it will look at 40, 40, 41.3. Where do you want to go? 41.3. It will check its routing table. Do I have entry for 40? something, something, something. No, it will drop the packet. Full stop. So if you ping, no communication. Understand the logic, guys? R1 can ping anybody here. There could be 254 guys here, but all 10 on 2, 10 on 3, 10 on 254, right? R1 can ping also here 21 and 1 because it has got 10 and 20 entries. But R1 cannot ping anybody in 30, neither this nor that, right? R1 cannot ping anybody in 40 because in its routing table it has got no entry for 30 and 40. Likewise, R2 has got only 20 and 30. So it can ping only here, it can ping only here. But R2 cannot ping anybody in 10, including this interface. And nobody here also in 40. Why? Because it doesn't know where is 10 network and 40 network. So it cannot. Likewise, R3 has no idea about 10 and 20. So it can ping anybody here, it can ping here, right? Because they are only 30 and 40. It can ping nobody in 20 and 10. So what do we do? Actually, then we go and configure some routing protocol, which actually will come after a month. You get my point? But look, what is supposed to be discussed after a month, we are discussing today. Of course, not in full detail, but at least giving you the fair idea, logic. So now R1, R2, R3. So now what's happening? This is 10.110, and from this subnet, 10.111, 10.112, 10.113, you can go up to you can give a lot of devices IP addresses, right?
DJ, I have a question.
Yeah.
Does that mean that it will only ping to the ports that are connected to it?
No. Now, assuming we have lots of switches and up to 254 guys, router can ping anybody there. You got it? You got it? Now I'm pulling this R1 here to create more space, and I have so many other switches, right, with 48 ports, right? And we have all devices connected on, let's say 40 ports. So we have multiple switches. You get my point? Maximum up to
Gee, I
254
have a
devices.
question,
Yeah,
sorry.
yeah, yeah.
If R1 has the ARP entry, then it can definitely ping R2, right?
Yeah, so what it will do is, if it doesn't have this MAC address, it will tell first send the packet. If you ping from R1, right, it will keep the ping packet in the buffer only and go and check its ARP table. If it doesn't have entry for 2112, which is this one, then let's say its MAC address is XXXX. Got it? So it will first go and send a ARP broadcast. Hello, 2112, send me your MAC address. So then this guy will send its MAC address. So then R1 will store, okay, 2112 is equal to XXXX is just an example. You get the point? And now it will send the ping packet. 1, 2, 3, 4. And if the connection is there, R2 will keep on replying back. Is the logic clear, everybody?
Yes.
Clear, na? No confusion, correct? So wonderful. Congratulations. You're understanding what I'm saying. Everybody, isn't it? So, where are we?
Protocols.
Where are we, man? 1 second. Now, what am I trying to say is, we took a topology like this time and again, R1 and R2 and R3 and again a LAN, right? So we have 10 dot here, we have 20 dot here, we have 30 dot here, we have 40 dot here. We saw this knows only of 10 and 20. This guy knows only of 20 and 30. This guy knows only of 30 and 40. So what we are going to do is, we can configure the static routing or default routing or dynamic routing. So let me just quickly give you some idea. RIP is not in our course, but it's a dynamic routing protocol. We could have configured RIP, or we could have configured EIGRP also. This is also not in your course. Or we have OSPF in our course, right? Open shortest path first. We can configure this. But the configuration is little bit, here it's very easy. Here it's easy. Here it's a bit tedious. So, but the way they function is same. I'm giving you the logic, right? Don't worry what we are using. Even if I configure RIP here, right? Or any protocol, right? It may be in the course or not, but I'm telling you what's going to happen actually. So supposing we go on these 3 routers and we configure some routing protocol, let's say RIP, right? And it's very easy. It's a child's play to configure RIP, right? Or EIGRP or OSPF also. OSPF a little bit more tedious, but so I'll focus only on RIP. or if you want EIGRP. Okay, let us not get into commands. Once I configure on R1, let me go to the global mode and just tell you how to configure it also, router RIP. Otherwise, you will keep on wondering, man, what's happening. Now we come under router mode, config-router. Now I'm going to advertise, give a command, type it, network. And this is 10, right? 10.1.1.1. Okay, and I'll give you more details later on, right? So I'll just type here 10.0.0. Again, I want to mic directly connected 20. So again, I'm going to type here network 20.0.0. So whichever interface has got addresses beginning with 10 and 20, from there it will start sending and receiving routing table updates. So what I'm going to do is, what the router is doing is now, it is advertising to its neighboring routers what networks it knows. So we are configuring this RIP routing protocol or any routing protocol on all the routers so that they keep on sharing the network information with each other. So what will happen is R1, R2 knows only about 20 dot and 30 dot, right? I'm not writing here completely, right? Something like this. 2110 or 20.000, whatever, right? Something like this, you know. But what R1 is going to do is, if you configure this routing protocol on all the routers, what will happen? R1, R2 cannot see anything behind R1, let's say. So R2 knows only about 20 dot and 30 dot. It's directly connected networks. It doesn't know about 10. So R1 will pass on this 10's routing information to this guy. So in RIP, R stands for RIP. It's a dynamic routing protocol. It helps the router to discover remote networks. So this automatically, he will send a routing table update to this guy and he will note it in its routing table automatically. 10.0.0.0. On which interface did I receive this? Let's say on my gigabit 0. So this entry R2 will automatically make. Then R2 will pass on its routing table entry to R3. R connected, it has got 3 entries, R2, right? R2 will pass on those entries which R3 cannot see beyond R2, which are what? 10 dot and 20 dot. So it will pass on 10 dot and 20 dot entry to R3. This guy will have now 10 entry and 20 entry in its routing table. How did I learn this? I learned it through RIP. And on which interface did I get this update on? Gigabit 1. Which means what? Tomorrow, if I get a packet from my right for 10 dot or 20 dot, right? So I'm going to receive on my gigabit 0. And 10 dot something something means I got to forward from which port? Or 20 dot forward for gigabit 1. So it will receive the packet on this port. It will look at the round table and say, okay, 10 dot or 20 dot means I got to forward from my gigabit 1 port. You get it? And from here, once he sends it, now here, if 10 is there, he'll forward, otherwise he'll drop it. Now, if the packet was for 10, he will receive the packet here and he'll say, what's the destination? 10 something, something, something. Okay, which port? So he will internally switch the packet from gigabit 1 interface to gigabit 0 interfaces buffer. And from here, it should be able to forward. You're getting it? I'm still giving you some rough ideas. It will come here, it will say 10. Do I have 10 entry? Yes. Which port? Gigabit 0. So from here, when it sends, it will go to 10. Got it? Now 10 is all here. Likewise, so what did I say? R1 passed on 10 entry to R2. R2 passed on 10 and 20 entry to R3. R3 will pass on 40 networks entry to R2. Get it? What will R3 do? It will pass on 40 networks entry to R2. So this guy will receive 40 networks entry through R means that dynamic routing protocol, RIP. Right? If you configure OSPF on all the three, it will not be here R, it will be O. O stands for OSPF. Got it? Something like this. Okay. But for now, we are just taking RIP. So R. And then R2 will pass on 30 and 40 networks entry to R1. So this guy will receive 30 network and 40 networks entry from R2. Routing table updates will be exchanged. How did I learn this? Through RIP. On which interface did I receive this? Let's say this is gigabit 1, right? Now, do all the three routers know about 10, 20, 30, 40? Everybody has got 4 entries? Yes, connected, connected. 2 are connected, 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 right? But after you configure routing protocol, RR, CC, RR, CCRR. R for learn through RIP routing protocol. That means they are remote networks, right? Could have been open shortest path first, but they are remote networks. So for R3, 10 and 20 are remote networks, correct? 10 and 20. For R2, 10 and 40 are remote networks. For R1, 30 and 40 are remote networks. Now, if PC1 pings the second PC, it will ping. Get it? Because the packet will come on R1. Router will look, what's the destination? 40 something. Do I know 40? Yes, I know. Which interface do I forward? Gigabit 1. So it will forward from here to here. R2 will say 40, 40, 40. Do I know? Yes. If not, I'll drop it. Which port? Gigabit 1. Right? So it will forward from this port. Because I had received this update 40 on my gigabit 1. So gigabit 1 for 40. R3 it will enter this port. It will look 40. Do I know? I know connected. Which port? Gigabit 0. So internally it will switch it and from here it will send like this. You get it? Understanding, guys? Easy or difficult? Yes, guys. Hello, hello, hello. Anybody
Why
there?
was it not able to send the packet on the packet tracer from
It was
PC1
not
to PC2?
from PC1 to.
PC2.
Have you configured RIP on all the three routers? Have you configured? Let's do it on our practical. See now,
Okay.
what does it have in its routing table? Have we configured routing protocol? No, we haven't, right? So
No.
let's go and do it. Enable. Show IP. Look, guys, this will come after 20 days, right? 30 days. This will come after 25 days. Don't worry. So today you don't have a tension, right? Show IP interface diff I showed you. Show IP route I showed you. I know only of 10 and 20. Look, R1. I have no idea about, I know about only 10 and 20. I have no idea about 30 and 40. Okay, guys. So look, let me go and ping 41 and 3. It won't ping. How do you ping? Yeah, good question, Dipti. Wonderful. Yeah, can everybody see the screen? Dipti's question. Yes or no? Yes or no?
Sorry, sir, it might be silly, but I'm just confused with that because initially when you told if ARP entry is there, it can ping to the other PC.
Yes.
So now if three routers are there and if all of the three routers have ARP entries, then no need of that protocol, right?
Very good. Thank you so much, Dipti. Wonderful. So you have 254 guys here. This guy may have all these 254 guys, including the switch, right? IP and MAC, IP and MAC, IP and MAC, correct? Because this is one LAN, correct? But ARP is only for directly connected ones. So here, if we add a switch and maybe multiple, so R2 will have all these guys IP and MAC up till this point, but not this. You get it? Not for remote ones. It's only for connected ones in the LAN. R2 can have only this one and this one, and everybody here in its ARP table, but not anybody in 40. You get it? They are
Okay,
only for connected ones, not for remote ones.
I get it. Thank you.
Wonderful question. Nobody has asked me such a beautiful question in past 20 plus years. Good, thank you. Now is it clear? ARP. So ARP was only for directly connected within our reach, only this much, right? So now what do we do here? We have 10 and 20, right? So I go here and configure some routing protocols. See, configure terminal, router. Look, this RIP is not in your course, right? But in the real world, if your company is small, your company may be using this routing protocol. And I'm going to type your network. What are my interface addresses? They are beginning with 10 and 20 only, right? So I'm going to type here 10.0 and network 20.000. That's it. 0.0.0. Done. That means whichever interfaces begin with 10 and 20 IP addresses from those interfaces, routing table updates will be sent and received, right? Here I'll go and say router RIP, network 20.000 and network 30.0 because I want routing table updates to be sent on gigabit 000 and gigabit 001 also. Sent also. And if my neighbor sends, I'll receive also on those ports. So I'm going to type here 20 and 30, right? Very simple, guys. Yes or no? Configure terminal, router, RIP, network, net is also okay, right? 20 and network 30. Done? Fine. So I'll go on the other router now here and type 30 and 40. Okay? Enable, show IP route, only CL 30 and 40. Configure terminal, router, RIP, network 30, directly connected, and network 40. Done. Control Z, directly 2 steps back. Show IP route. I have only 30 and 40. I should get, now R2 should be sending me information about 10 and 20 also. But it will take up to 30 seconds for the routing table update to come. So I'm just waiting, just going up and down. Look, within 30 seconds. Now R3 says, I know information about 10 and 20 also. Got it? Understood? So this guy took some time to send this guy information about 10 and 20, which both are remote for R3. So now R3 has got information about remote networks also. R stands for RIP, which is not in your course officially, but in real world, companies may be using it if your company is small. Now look, we are not discussing RIP because it's not in the course, but I received this update on which of my port? Gigabit 1. So if I get a packet, R3 says, if I get a packet from, let's say from my right, for 10 or 20 or 30, I should forward from my which port? Gigabit 1 port. Na? This is gigabit 0, gigabit 1. So look, 10, 20, 30, all will be gigabit 1 port. 10, gigabit 1 port. I should forward. If I get a packet for 20 dot something, I should forward from my gigabit 1 port again. And 30 also, if I get, no, 30 is directly connected, right? Of course, but gigabit 1 only. Okay. And look, we don't have RIP in the course, but RIP, routing protocol, routing information protocol, that's the full form of RIP. So what happened here? Ten dot, 20 dot, 30 dot, 40 dot. Connected, 10 and 20. Connected, 20 and 30. Connected, 30 and 40. Now, this guy sent 40 to this guy. Okay, gigabit 0, gigabit 1, gigabit 0, gigabit 1, gigabit 1, gigabit 0. Now, this guy sends 40 to this guy. So, through RIP, he got 40 information on which port? Gigabit 1. I received update on which of my port. So, tomorrow, if I get a packet from my left for 40, I'll forward from my gigabit 1 port, right? Likewise, R2 sends to R1 30 dot and 40 dot network. How did I come to know? Through RIP. Which of my interface did I receive this update on? My gigabit 1. So tomorrow, if I get a packet from my left or anywhere for 30 dot something or 40 dot, I should forward from which of my port? Gigabit 1 only, then only it should reach 30 or 40, correct? Likewise, R1 must have given 10 information to R2. R2 received on gigabit 1. So 10 information I got to RIP and on which port? Gigabit 0, sorry. Right, this one, correct? And now R2 will pass on 10 and 20's information to R3, but R3 receives this update on which of its port? Gigabit 1, right? So like this. Now is it okay? Now if you ping from this PC, it will come here to look at 40, I know, gigabit 1, send. And from here, it will send here. 40, 40, yes, again gigabit 1 here. And he'll send to this guy, 40, yes. And this is gigabit 0 and this is gigabit 1, right? It will send from this. But what's going to happen? Now look, one more small change in this. Not change, but I'm adding some more information now. Let us say this is A1, the MAC address. Let us say this is A2, MAC address of gigabit 0. Let us say this is B1. Actually, you know it is 48 bits, but I'm just writing in short. Let's say this is B2. Let's say this is C1. Let's say this is C2. Let's say this is D1. And let's say this is D2. So when the PC1 sends a packet to the other PC far end, what will be the source IP address? It is 10.1.1.3, correct? What will be the destination IP address? It will be 40.1.1.3. Yes or no? Yes or no? What will be the source MAC address? A1, A1. What will be the destination MAC address? Yes, guys.
A2, A2.
A2, A2, correct? It will be the default gateways, isn't it? And not D2, D2. Is this clear to everybody?
Yeah.
It will be A2, A2, correct? Good. Wonderful. Thank you so much. Who answered? Who answered? A2, A2. Hello, hello. Who answered my question?
Yeah.
Who? Oh, Karthik, you answered. Okay, thank you.
Karthik.
Oh, good.
Yeah.
Okay. Because sorry, I don't come to know who answered, right? But slowly we'll get used to your voices. Beautiful voices, right? Must be Karthik anyway. Okay, so now, so the packet comes till R1. Has it come? Packet should come till R1, right?
Mm.
Through the switch, it should come till the default gateway, which is R1. So now here's the packet. Now what will the R2 do? R1 do? Look at the routing table 40. Send from gigabit 1. Internet will switch from gigabit 0 to gigabit 1 interface buffer. But before forwarding it out, right? After checking, it knows from gigabit 1 I go to check. What will it do? It will remove this R2 before forwarding out the packet. It will remove this MAC address of this guy, right? This stories end here. Now new chapter begins. So it will put its own MAC address here, B1, B1. You get it? And now it has to forward to whom? To R2 here. So who's that? 2112, right? So it knows from this port I got to forward. Who's the opposite end? It will tell, hello, who's 2112? Send me your MAC address. It will take this. And now it will put this destination's MAC address. What is that? B2, B2. Correct? And now it will send the packet from R1 to R2. It will come here on this port. Yes? Now R2 is going to look at destination. Where do you want to go? This source and destination IP addresses will never change. 4113. Do I have 40 in my route table? Yes, gigabit 1. Again, internally, it will switch the packet from gigabit 0 to gigabit 1 interface. Before sending out from gigabit 1, what it will do? It will remove this MAC address. Old story B1 gone. It will put its current this interface outgoing ports MAC address. What is that? C1, C1. And it will put this guy, hello, who's 31 and 2? Send me your MAC. You're my opponent here. I mean, just opposite me, right? C2, C2. It will put here C2, C2. And then shoo, it will come here. Now it has arrived here. Yes, guys, understanding the logic, whole sequence, easy? Yes or no?
Yes.
Good, thanks. So now where is it? Here? Now it will look at destination. What is it? 4113. Do I know 40? Yes. From which port? Gigabit 0. Again, it will receive the packet here. It will shift. Internally, it will shift the packet from gigabit 1's interface buffer to gigabit 0. But before sending out, it will check its ARP table. Do I have this guy's MAC address in my ARP table? ARP table. No. Then before sending out that packet, first it will send the ARP broadcast. Hello, who's 4113? Send me your MAC address, please. It will broadcast means FFFF 255. Switch it receives on this port. Switch will look at the MAC address. FFF means it's a broadcast. I'll receive on this port and make Xerox copies and give to everybody else. All these guys are going to say, I am not 4113. It will come here also. You will say, hey man, I am 4113. What do you want? You want my MAC address? Take it here. It will give to router. Router will in its ARP table make an entry. 4113 is equal to D2, blah, blah, blah. And now it will change. Before sending out, it will put its MAC address. What is this? D1, right? D1. Source. And destination is D2, 4113. So it will remove this and put D2. Got it? Now you know what will happen. Packet will come on this switch interface. Switch will look at the incoming frame source MAC address D1. In its MAC address table, it will check. Do I have D1 in my source MAC address? No. If yes, nothing to do. If no, it will make an entry. Which port did it come on? Let's say fast 0/1. And do I know where is D2, D2? No, I don't know. What do I do? Unknown unicast address, flood it. So it will receive on that port and it will make a Xerox copy. And what? It will give to everybody else. These guys will say, I am not 4113, I am not 4113, I am not 4113. This guy is going to look in the header. It's my MAC address. It will pull out the copy of data from the cable. Got it? So if it was a ping packet, first packet may get dropped, right? Whatever, because he may be busy, right? Whatever. Or if the entry was already there, he will reply. Anyway, but the second packet, he should be able to reply back. Third packet, he should be able to reply back. Fourth packet, he should be able to reply back. PCs send only 4 packets, but routers and switches send 5 packets. Understood the whole logic, guys? Now, this is the crux of the whole course, which should not be taken in the beginning. But there you go. Has it helped you improve your understanding? Yes or no? The bigger picture. Now we have all 10, 20, 30, 40. See? So let's go on the PC and ping. Who's that? 4113? Yes. 4113, right? Correct. Look at the top. And default gateway is in the left hand side, right? 41.1. That's correct. Let's go and ping 4113. Will it ping? Up arrow. 4113, man. Oh, 4113. It's 4113. 1.1.3. Sorry, my mistake. Does it ping? If no, problem. If yes, congratulations. Cheers. Yes, see? First packet timed out. But 3 got it. So yes, guys, all working. See? Routing. See that? There could be cloud in between. This could be in India, that could be in London, something like this. Okay. Only for the sake of understanding. Yes, guys, now give me a feedback. You understood this big picture? How end-to-end communication happens. So we had to configure some routing protocol, right? Otherwise, this guy doesn't know about 30 and 40. He knows only about 10 and 20. This guy knew only about 20 and 30. He doesn't know anything about 10 and 40, which are remote networks. This guy knows only about 30 and 40, which are directly connected. He doesn't have any idea about 10 and 20 also. Yes, guys, now tell me. Most of the guys have left. Supraja, Neeraj, Karthik, Dipti, Bharat. Is it very difficult? Or is it easy? Or okay? What is it?
I'm getting it, EJ. Like 70,
Yeah.
80%.
Oh, good. Wonderful.
So I will try on my side with the packet
Yes.
tracer
Yeah, you
and
can
will
try.
confirm.
Yeah, no problem.
Same here,
But
sir.
yeah. So, but you understood the concept, right? What exactly
Yeah,
is happening?
conceptually it is okay. Yeah.
The
Uh,
commands, don't worry about the commands.
RIP is right so easy.
Very easy, man. But
Yeah,
RIP is not in your course. But routing is routing, right? Whether you configure RIP or
right,
EIGRP
right.
or OSPF, right? So
Yeah,
finally, we'll
the
be
protocol
configuring
that
OSPF. Yeah.
yeah.
EIGRP also I
But
will show you, but it's not in your course. But many of the companies may be in real life using EIGRP. They may not be using RIP. They may be using EIGRP. They may not be using OSPF, right? But your exam and course says only and only OSPF. But I am giving you, because configuration doesn't take a lot of time, right?
Mhm.
And we are not getting deep into EIGRP and RIP details, only the practical configuration. But we'll get into the
Right.
depth of OSPF even beyond this course, right? Okay, it says my internet connection is unstable. So if I lose it, no problem. चलो तो समझ में आ रहा है, right? Understanding, isn't it? You can take your own time and try and do this at home. Of course, we don't need to do it today only. I mean, you can do it, but this topic nobody will take today. But just to give a big picture of how end-to-end communication happens, right? I give you this practical, showed you this practical rather. Okay. So we have another 15 minutes left. So, and now if you want to save this, right, topology also, you can say copy, run, start. Right, just copy, run, start. That it will save from RAM to NVRAM. Alternatively, you can just say WR, right? So now we have all this command saved. Tomorrow, again, if we come and open this, we'll get all this configured, right, and saved. Otherwise, if I don't save this, enable, show, run, we have all these commands, right? R2 given means we have configured a little bit. And of course, look, we have configured some IP addresses also, right? And they are enabled. And we have configured some routing protocol RIP also, correct? So now if I have a look at show start, which is startup config, right? That means NVRAM. So there's nothing there. So if we turn off this router tomorrow, we'll lose all commands, right? So before we go home, we'll say WR or alternatively copy from my running config to startup. So you can give whatever, whichever you like, right? WR will also work in the exam also. This means write. Same as copy, run, start. So, and now I'll go on R3 also and similarly give the command. On PCs and switch, we don't have to give it, I think. Switch also I can save, but PC I don't have to give WR. Okay, so saved it. No tension. Tomorrow, if we open this on the PC, we don't have to do it anything. Right? On the switch, we can go and say, if at all, WR, right? Or copy and start.
Sir,
So now,
what if we are going to save the file, like file and save? Will it be saved?
uh, yeah, it will be saved. What is your question?
I'm saying that you mentioned that we have to write the config on the routers and the
Hmm.
switches.
Hmm.
So I'm saying that if we have made the changes, then if we just save the file in a packet tracer
No, 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 no.
file,
But
it will not
no,
be
no, 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 no. If you don't say here this
okay.
command, this or this,
Mhm,
you will lose all
mhm.
your command. You will get the topology tomorrow, right? With the switch and
Okay.
PC, everything.
Topology will
But
be there, but
yeah,
config part will not.
absolutely. You lose all the commands, right? And we want both,
Okay.
isn't it?
Right, right,
So therefore,
right.
without fail, first go and say copy and start, copy and start, copy and start on the switches also, right? On the
Right.
switches also. And then you can save the topology. So when you open tomorrow, you will get both, right? The purpose is to get both. Nah? No point getting the topology only because we want the commands also. Along with commands means IP address is everything, host name, right? And this is only a small trailer, guys, right? I'm trying to make it as simple and as easy to understand. Even a layman should be able to understand this, isn't it? What now you understood the purpose of routing table, right? What I know, what R1 knows about 10, he informed his neighbor R2. R2 informed R3 about whatever entries he has got, 10 and 20, which means R3 cannot see behind R2. So R1 informed R2 about 10 network. R2 informed R3 about 10 and 20 network. And R3 informed R2 again about. So R3 will send this routing table update to switch also on the right. But that's a layer to switch. So he will send that routing table update to switch also containing all this 10 and 20 and 30 network. But switch 2 will drop it because he says, no, he will just flood it without understanding. He says, man, this is a multicast or a broadcast. And switch, what do? If they receive a multicast or a broadcast, they receive on one port, make a Xerox copy and give it, forward it to everybody else. That's it. So all the pieces are going to drop it because they will say, what is this, man? I don't understand. What is this routing table? Switch will say, I don't understand this because I'm a layer 2 device. I don't understand our routing table. That's a network layer funda. Anyway, so in the real life, we'll go there and we'll give a command on this router and say, stop sending routing table updates to the switch here on the right. No point. Because RIP, every 30 seconds you are going to send here and there, whatever interfaces are 30 and 40. So throughout the whole life. So throughout the whole life, every 30 seconds, if this router is going to send routing table updates to this switch, and there were 90 more switches connected below it. Every switch had got 48 ports, and there were 40 hosts. That means hundreds and thousands. So every 30 seconds, it will go to this switch. You will send to all these devices plus that switch, plus all the devices, second switch to third switch to 100 switch, right? Third, fourth, fifth, like this. Waste of CPU cycles, waste of bandwidth, no point. So we'll give a command and tell him stop sending here. Only send round table updates here. right? Likewise, here we'll say you send here, but not there. Okay, so but all these things don't matter right now. Yes, guys, understood this much. So look, we took a 3 router, 2 switch, and 2 PCs, and end-to-end communication I showed you. Now we don't have a lot of time today, but so where is our TOC? Table of contents. Everybody has it. Do we have TOC?
Yes, yes.
Sequence 8 p.m. This is your TOC right here. So big picture, we have done it, right? So can I strike it off? See, like this, we'll keep on doing. Is it okay, everybody? Introduction to packet tracer, housekeeping commands. No, I haven't done this. I have showed you only a few commands. Structure of IP address, 32 bits, binary. MAC address, 48 bits. We have completed this much,
Automation between
isn't it?
right.
But we'll strike it off tomorrow. And then now we'll get into basics theory, protocols and topology and differences between all these things, right? We'll look at all these things in theory first. Okay. So I hope today's day was
Just
okay. Yeah.
just one question. Like there are so many different series of routers. Like
Mhm.
they are all serving same purpose, but the series name are different. Any reason for that?
A lot of hardware platforms or series and a lot of iOS versions, right?
Yeah,
So more or less from our
exactly.
point of view, more or less from our course point of view, it doesn't make any difference to us, right? Unless until
Okay.
you are into a CCI level and right, you are talking about very high-end
Mhm.
things. So some of the features may not be supported by some iOS or some hardware platform, right? So
Okay.
for this course, nothing to worry.
Fair.
DJ, what is the difference between subnet and subnet masks?
Ah, subnet mask and subnet. Who's asking? Karthik?
Yeah.
Good. Subnet and subnet mask. Okay. Subnet mask tells you, subnet mask tells you, subnet mask tells you how many bits are in the host portion, how many bits in the network portion, right? And how many bits in the host portion. But of course, if you know IP addressing, you will understand. If you don't know, then I will have to explain first IP addressing and subnetting.
I don't know that.
Okay, don't worry. So subnet mask only tells you how many bits are there in the network portion and host portion. So now you don't know IP addressing, right? At all.
No, no,
Okay. Then
zero.
give me at least these many hours to explain you this. How many
Okay.
hours? Got it?
Three,
It's
four,
a
four.
ocean. It's a ocean. Now subnet mask, you will come to know when we talk, when we have spent 3, 4, so many hours on only discussing IP addressing and subnetting. Subnetting means this is one network, one cake, right? So no subnetting, no subnets, only one network. But if you take a knife and cut the cake into multiple pieces, this is one subnet. Subnet portion is a smaller portion of the bigger network, right? That you understand, correct?
But then what's the difference between a subnet and a VLAN?
They are correlated. So first,
Because both of the things create boundaries.
correct. You're right. So see what we have to do is, I told you if we are 100 users, right? If all of them are in the same subnet and VLAN, let's say all of us are in VLAN 1 only, correct? Yes.
Yeah.
So all ports belong to VLAN 1 only. All these ports, they by default belong to VLAN 1 only. Now very advanced things you're catching up right now, right? Okay. And everybody's IP address is, let's say in 10.1.1.0/24 subnet, which means what? Right from 10.1.1.1 to 10.1.1.254 addresses we can give. Okay.
Mm.
Now presume it's all 255, 255, 250. Now all of us are in VLAN 1. So if one sends a broadcast, what will happen? It will go to how many other devices? Let's say 254, up to 254 devices, correct?
Okay.
Or 253 devices. Okay. Because total is 254, right? Total IP addresses or devices we can have it with this. Now the subnet mask decides how much host we can have. So it's a big topic, right? Total we have 254 hosts. If one sends a broadcast, it will go to how many other devices? 253. So entire bandwidth will be eaten away. So, but in the real life, what we do is we don't keep all this 254 guys in one subnet. What we'll do is, as per department or project, right? As per so your company has got how many departments? IT department, many departments, right? IT department, and what? Accounts department, and what? Purchase department,
Manufacturing.
marketing or sales, right? What do you call? Yes, manufacturing department, right? Sales, so many other departments, right? So let's say we got 20 guys or whatever. Let's say approximately, right? We got, I don't know, man. So if I make a round figure, it's okay. But let's say we take some 50 guys in one department, right? So then what we are going to do is we are going to now I'll just change this figure. Let me take it 300, right? And we will take 30 guys just for the sake of simple mathematics, right? We got 10 departments. How many? 10 departments, right? And because this calculation will be tedious, so we'll have 30 guys in one department. You get it? But now what we are going to do is, so 30 guys in one department. I'll have to change the color, man. Let's say they are 30 and another 30 in another department, right? Another 30 in another department. It's just a demo, right? It's just a small example. And we'll put these guys in, let's say, VLAN number 10. We'll put these guys in, let's say, VLAN number 20. Let's say we'll put these guys in VLAN number 30, so on and so forth. We'll create 10 VLANs, 10 departments. And now from IP addressing point of view, if you use an IP address of like this, 10.0.0. If you take this network and /8, which means what? Like this. This now, if you don't understand IP addressing, it's difficult right now. It's only one network and no subnets. So you can have lakhs of addresses. But we are not going to do this. We are going to break this one big network into smaller subnets, right? Later on. For that, you need to understand IP addressing and subnetting. For that, I told you, you have to give me how many hours? 3, 4, 5 hours, right? And
Okay.
we'll have 10, maybe we'll have to do a lot of subnetting, right? Like this. And another will be 10 dot, maybe 2.2.0s or 10.1.2.0. Another, I'm making it simple, right? 10.3.3.0 to /24. Likewise, we'll have different subnets. So for every subnet, we'll have a different subnets. For every VLAN, we'll give different subnets IP address. So now what will happen? If one sends a broadcast, it will not go to 299 guys. It will only go to how many guys? 29 guys. Understood the logic? So what will happen?
Yeah.
Your bandwidth usage will come down. So the performance of the network will go up. The remaining bandwidth will be utilized by the end users. It will not be eaten away. But this is a very advanced, I mean, from this course point of view, it's a something advanced topic. From this course point of view, right? It is a very, it should not be discussed on day 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Okay.
Got it? But because you have some idea, but those who don't have any idea, don't worry. I'll take you from scratch. Okay. ठीक है, Karthik, Neeraj, all okay?
Yeah.
Yeah,
So then we can
I do
meet.
have some clear idea.
Yeah.
Okay.
Any questions, any doubts?
No, DJ. That's all.
No, so far, so
Okay. So don't worry. I need a lot of time, man, to cover up all these things. But so far, so good. ठीक है ना?
Yeah.
Great.
yeah, yes.
Chalo, then we'll meet tomorrow. Okay?
Okay. Good night,
Yeah,
DJ.
thanks. Yeah, good night.
So
Bye.
next